See, we'll see one interview question like what is index? What is the advantage of index? What is the disadvantage of the index? See, index is a schema object that contains entry for each value that appears in the index column. See, everybody know like the textbook will contain the index page. The index page have like all the topics with the page numbers, right? If you want to reach like a take it is as a Oracle textbook. So now if you want to reach like you are looking to learn or if you want to see the constraints concept in your textbook. So that may be in it. Look like I say, we have the book having like 1,000 pages. The constraints is in the middle of the book like a 500 page, right? So you no need to search from the from first page to the till 499 pages. Okay, so you are like ignoring these many pages because you already know this topic is in this middle of the book, right? See, if you know that you are able to reach your destination faster or you are able to reach your destination page faster with the help of index. The same way, if you have the table like any table, okay, see the table may have like lakhs of records, the crores of data. Okay, in that particular table, so if you are trying to retrieve any data, if you don't have the index page or index on the table in such place, you need to look the value from first record to the till last record because you don't have any address ID to whom like to which person you are trying to find that you don't have any address ID for that. So whatever the person you are looking, the constraint concept is you got in the first page also, you need to go with all the pages to verify is there any other pages having the constraint related matter, right? See, to do that, we'll create the indexes on top of the table. Okay. See, treat like as the meanwhile we'll see about okay. So let's start from employees. So this is table is having like only 100 records. So 109 record. Now if you are trying to retrieve the data where employee ID equals to 101. Now you are getting the data employee ID in fraction of 0.8 milliseconds, right? Because this table is already having the index name. This table is having already index. That's the reason you are getting the data fast. See, now you can try to get the data. So we are creating some dummy table with the get table, create table, table name TT underscore EMP is my table name and I'm creating this. Okay. Now I'm trying to retrieve the data using this table. See, earlier you are getting like only 0.08 milliseconds, but this is taking like a 0.48 milliseconds because this table does not have any indexes. This table does not have indexes. See, no indexes available for this table. Okay, see in this case, if you are creating the index on this table, this will improve the performance. So meaning, if you create the index, directly it won't improve the performance. If you create the index, see, if while creating this index on any table, it sort the data. See, if you create the index on name, all starting with A letters in the first position, B letter in the second, C letters in the third, Z is the last position. See, in this way, the data gets sorted and creates some address ID for every record. So then you will get the data. So if you are trying with value, so it won't look for the greater than B. So if it reads like C, the search operation going to stop. Okay, you are looking at the B letter, B word starting with B. So I won't go with the more than that. So if we create the index ID on employee ID column, index on employee ID column, so the data gets sorted in this respective order. See, the data is sorted and stored in the behind. It won't like, see, if you see your data, the data how you are inserted in this way, particular way, the data will be stored first in first. So if you are in the, I'm the A letter name, so I don't want to in the last position. So I need to be in the first in the sense it won't happen like that. Okay. So the data is sorted and stored in the backend. It's not required for you. It's not my job. So that's a Oracle job. It's sorted and keep the data in the sorted order. Okay. So by littering of the data, definitely it will improve the performance. Okay, it improve the performance. So you have two types of indexes. We have two types of indexes. See, one is B tree index and bitmap index. B tree index is the default index, so which we are creating on the daily basis. That's the B tree index. See, B tree index will create for the high cardinality columns. We will create the B tree index. So what is the cardinality here? What is the cardinality here? So the cardinality is, so if you are, see, you are mentioning like select star from TEMP, employee ID equal to 101. See, what are the column you used in this where class? That particular column, how many distinct values we have? Distinct. From PT underscore EMP. This we can call it as a cardinality. Cardinality. So the distinct values of that particular column, so we can call it as a cardinality. If it is having only two distinct values for entire column, that we can call it as a low cardinality. If it is greater than two, the distinct values, that we can call it as a high cardinality column. High cardinality column. See, if you want to know about this cardinality, simply press like a F10. It gives the explain plan of any query. The explain plan meaning it is prediction of to run that particular query, how much memory I'm going to use, how many records I am going to pull, that how much cost I am going to, how much memory, this cost in the sense, I'm going to use 3 bytes of memory in the CPU. I'm going to pull like a 109 records from this table. Cardinality, number of rows, distinct rows. Okay, so this is about like cardinality. And see, here it is going for the full scan. The table access is going for the full. The table access is going for the full. We need to avoid this full scanning mechanisms. Full scanning mechanism in the sense, if you create the index page for the book, you no need to look the value like where is my concept, where is my concept. You no need to search for the all the pages. Right? If you maintain the textbook, see the textbook will contain the index page for that reason only. Okay. Now, now you got like a B tree index is the default index and bitmap is the another index. See, high cardinality columns we are creating the B tree index. See why we are calling as a tree here. Now, treat like I said, this is your all employees we have. Okay, this is your employees. So treat like I said, this is the value suite. Now, if you create the index on this particular table, record or column, okay, the data gets sorted and stored in this particular order. Now, split the data into the two parts. split the data into two parts. See, all ones will come to this place. One, if you have like more than one, it will come to this place. Now we have three times, and three we have three, four times, and we have the fours like three times we have fours. See, if you have 20 records in this, it's splitted 10 records in one side and another record, another 10 in the another side. See now it splitted the data 5 okay 5 three times, and we have 6 only one time, and 7 we have three times, and 8 also we have two times. Okay, and we have 9 two times. So this is the way it splitted the data into two parts. If it is the odd number case, so one set will contain one extra record and another set it contain one less record. Okay, so that based on system can define. Now you are searching the value like a 4. Okay, so it search the value like a, see, I'm going to add one more value in this like a 4. Mistakenly the data is not sorted or something like, or the data will get in this place. Treat like I say. So I splitted the data into two parts, right? So the data is came in this place. Okay, now the data is in this like. Now you are searching like select star from table name where employee ID equal to 4. Right? Now you search the value. Whether the searching value is present in the first set or not. What I'm going to search, that value is in the first set or the second set. I'm going to look that value. If the value is present in this first set, I will put it is active list, and I will search for in the second list as well. If the value is present in this, I will put it as a second active list. If the value is not present in this, I will ignore this, and I will ignore this second of records, and I will continue the search operation in this particular first set only. And again, I can split this data into one more time like 1, 2, 2, 2, 3, 3, and 3, 3, 4, like this. If the value is present in this first set, again, the node is becoming like every node will split it into the two nodes until our get our NQ value, until our searching value. If you get like a 4, wherever I'm getting, see now the search operation will continue in the two active sets. Okay, now it find like a 4 is not present in this. It ignore this value. It ignore this set of records, and the search operation will continue into this 3344. And again, it split the data into this 334. I split the data into this. So 334. Maybe it come to this place 4. Again, it have the two active sets 334. 4 is present in this. Then it come to this 33 and as the 4. Here you have only the so these records can ignore in this place, and this going to display for you. This going to display for you. So this is the way the search operation is performing as a tree manner. That's the reason we are calling as a tree, B tree. Okay. So this is about the B tree index. By default, this index will create on the tables. Okay. So for that, you no need to, the syntax will be look like this. Syntax look like this. So create index name on table name of the column name. This is the syntax. Simply, if you want to create index name, whatever the index is. So just I mentioned like a B tree index on employee of of column name. So that may be a, so what it is, we have first name, treat like as a first name. Okay, so this is the syntax for this. Okay, now you created this. Now I'm trying to create the same index on my TT underscore employee table. TT underscore employee table. See, to fetch like a 101 record, it took like a 0.48 milliseconds. Now I'm creating the index ID on employee ID, just employee ID. Now index got created. Now try to retrieve the data from this now. Earlier, it took like a 0.048 milliseconds. Now it took 0.01. So you are able to save this time. So meaning you are able to retrieve the data faster using this index. And we have another index. We have another index. So where we have the low cardinality. So the gender will have only two genders like a male or female. So in this situation, we'll go with the bitmap index. We'll go with the bitmap index. Okay. See the syntax for the bitmap index. Simply the B tree you no need to mention, but bitmap you need to mention. Create index. Create bitmap index. Create bitmap index and index name also you need to mention. No need to mention like bitmap here. So that you need to be aware like so B index and the gender column that I am going to create. Now bitmap future is not enabled because it's a trial. It's in like standard versions, not as a professional versions. Enterprise editions or company people will use enterprise edition or professional editions. So these people will have the access to create the bitmap indexes. Okay. So we don't have option for this. We have two indexes. So if interview asks, we need to give these two only. Is there any other indexes? Yes, we have other indexes as well. We have other indexes as well, like a function-based index. Function-based index. See, if we are creating any index based on any function or with the help of any function. See, now you created the index. Now you created the index and you are trying to retrieve the data. While retrieving of the data, you are not like pulling the data using the direct column. Now I'm trying to use like a 2 underscore number of employee ID equals to 101. Earlier it took like only 0.01 milliseconds. Now I'm trying to retrieve. See, now it is taking 0.06 milliseconds. So it increased like a 0.05 milliseconds, right? So we can reduce this simply by creating of index with the help of this particular function. What are the function you are using in the where class? The same function you can try to create with the index. 2 underscore number of employee ID. I'm dropping this index and I'm recreating it. Okay. Now I'm creating PID. So the name like naming conventions you need to follow very clearly. Okay. Now I'm trying to retrieve the data. See 0.01 milliseconds came back because I created what are the format you are using this column in the where class, the same format that the same functions. I make it as say index. Okay, this is the advantage of the function based index where we are creating the index based on the with the help of any function or based on any function. It may be a substring function, in-string function, upper, lower, any function. Okay, this is about like a function-based index. Is there any other indexes? Yes, we have one more index, unique index. Unique. If you are creating like a primary key constraint or for unique constraint, okay, if you create like foreign primary key or any key constraint, by default, it create the index for that. That index is a unique index. Unique index. Unique index you can able to create manually as well. Now I'm dropping this index and I'm recreating it again. Instead of directly simply mentioning like a unique index. So it's added like a function based with unique constraint. Now I'm dropping this index and I'm creating with the normal unique index. Okay. Now if you retrieve this, it won't retrieve like 0.02 milliseconds because of this. You can remove this 2 underscore number function 0.0 milliseconds. 0.02 milliseconds. Earlier it took like 0.01 milliseconds. 0.01 is greater than 0.02 milliseconds. 99 paisa, 0.9 in the sense 90 paisa. So here it is like a 0.02 milliseconds. Okay. So it's like a less time here. If we use any Q constraint, the such operation will take very less time compared to the normal time. Okay. This is about the indexes. You need to be answered. It's a very, very important. Definitely everybody will ask this. Is there any disadvantage of this function? Sorry, indexes. Disadvantage of any indexes. So disadvantage of these indexes will be the searching operation is getting improved while inserting the data into the table, while performing of the DMLs on the table. The DMLs will get slow because see, if you don't have the index on the table, you are inserting like millions of data, and you need to insert any additional values for your records. If I am inserting the data into my table, I need to create some index value for every record. To generate that index value, it may take some time. That time you are going to, that time you are going to lose. I mean, that time you are going to get the performance issues. If you compare to the normal thing, you cannot able to go with like a index while. So for that reason only, we'll drop the indexes on the base tables, on the transactional tables, or we'll disable and we'll push the data into the table and we re-enable the indexes. Or we can drop the indexes and push the data into the table and we can recreate that index. This is what we will do in the indexes. Okay. So is there any other important things? Difference between view and okay. See what is view, what types of views we have. We see. Okay. See, view is a virtual table. View is a virtual table. View is a database object which is used to store the SQL statement permanent, not the data. View is it's a database object. All the database objects won't be store the data, but table is only one database object which is used to store the data in the Oracle or database. Okay. Now, view is a database object. The view is also storing some information. It's a query. Whatever the query you are writing in the database very frequently. See, you are doing some repeated query writings on the daily basis, like hundreds, 100 lines of code on every day. Instead of writing like every day of the same code, we'll make it as a view on top of that particular query. We'll make it as a view on top of that particular query. So we'll use this from next day onwards, simply using like select star from ABC view. What are the query you are writing and pulling that information? The same thing can happen in the backend. If you are calling this view, that we the query inside that view, whatever the query we have, that pull the information, provide that to us. See, view is a virtual table because view won't store any data. View is won't take any space also. Okay. So now view is a database object which is used to store the SQL statement permanently. See, if you see like a select star from user underscore views, select star from user underscore views. See, view name emp underscore details underscore view. It have like a this entire data. See the view inside the view, how you created this particular view. This is what you're going to pull on the daily basis. See, definitely it may take some time to write this particular query, right? See, I'm going to save this time. I'm going to save this time by writing a simply as a view. Instead of writing this many, this much big query, simply I'm creating like view, create view, vw underscore sample, create view name as select star. See, if you see like if you go with the vw underscore sample view, vw underscore sample, sort the view in this, and go to this now. See, the view got created with this particular statement. Okay, view is a virtual table because if view is an actual table in the sense it takes some space in the database in user underscore, let's start from user underscore segments. So whatever the object you are creating, if that object is occupying any space in the database, that all the objects will stored in a user underscore segment with the segment name equals to, we created tt underscore emp table, right? So tt emp is the table name. Now I'm pulling this. See, it is having the entry in the segment table. Now I created the view with vw underscore sample, vw underscore sample, right? vw underscore sample. Now I'm going to use in this segment. Okay. Now I'm trying to find this. I'm not seeing any entry in this because view is a virtual table. It's not a table. So view will always store the data in the base tables. So view is acting like as a Swiggy Zomato. The table is acting like as a restaurant. The restaurant is having the capacity to cook the food, the storage device, everything is having. But Zomato and Swiggy does not have any storage device. They are depending on the tables. Okay, view is a virtual table and it have like two types of views, simple view and a complex view. See, if you are creating any view, if you are creating any view based on only one table, that we can call it as a simple. If you are creating with more than one table of any view, if while creating of any view, if you are using any like more than one table, that we can call it as a complex view. See, in the simple view, you are creating with only one table If you are using any group by class or any derived column, sum of column name like that, that we can call it as a derived column. If you are using any derived columns in the simple view, I mean in the single table, that also will becoming like as a complex view, not as a simple view. Okay, and you can able to perform the DMLs. It allows the DML, but in the complex view, you cannot able to do any DML operations. Is there any way? Yes, we have the way by using instead of trigger, you can able to perform the DML operations. Okay, these two we done now, so we'll see in some time later.